Kubernetes is not just for running stateless applications, for example, microservices, but also excels in running more complex, stateful, or system-level workloads that require specialized configurations. These advanced workloads in more detail: jobs, CronJobs, DaemonSets, StatefulSets, and Init Containers. Here's a deep dive into each. 1. Jobs. Definition: a job in Kubernetes creates one or more pods and ensures that a specified number of them successfully terminate. Jobs are mainly used for running batch processing tasks or workloads that should run to completion, i.e., one-time tasks. Use cases: data processing pipelines, ETL, sending notifications or emails, running database migrations, performing backups. Key features: completions. You can specify how many pods must run to completion, spec the completions, useful for parallel jobs. Retries. If a job's pod fails, Kubernetes automatically retries it, configurable via backoff limit. TTL, time to live. You can clean up jobs automatically after they complete using TTL, seconds after finished. 2. CronJobs. Definition: CronJobs manage periodic tasks, jobs, in Kubernetes. They are similar to jobs, but are scheduled to run at specific intervals, similar to Unix CronJobs. Use cases: running scheduled backups, periodically generating reports, automating daily batch processing tasks, cleaning up logs or temporary data. Key features: cron expression. CronJobs use cron-like syntax to specify the schedule. Concurrency policy controls how jobs are handled when one is still running. Allow: all jobs can run concurrently. Forbid: skip new jobs if the previous one is still running. Replace: cancel the running job and start a new one. Starting deadlines ensures that jobs that miss their scheduled time don't start after a delay. 3. DaemonSets. Definition: DaemonSets ensure that a specific pod runs on all or some nodes in your cluster. When new nodes are added to the cluster, the DaemonSet automatically deploys pods to those nodes. When nodes are removed, the corresponding pods are cleaned up. Use cases: system monitoring tools, for example, Prometheus Node Exporter, Fluent, or FileBeat for log collection, networking proxies or VPN daemons, security agents that need to run on every node, distributed storage agents. Key features: node selection. DaemonSets can be constrained to specific nodes using labels and selectors. Update strategy. You can specify how DaemonSet pods are updated, for example, rolling updates. Auto-scaling. While DaemonSets don't scale in the traditional sense, they scale automatically as nodes are added or removed from the cluster. 4. StatefulSets. Definition: StatefulSets manage the deployment and scaling of stateful applications. They guarantee the order and uniqueness of pods, which is essential for applications that require stable identities, like databases and distributed systems, for example, Cassandra, Zookeeper. Use cases: databases, for example, MySQL, PostgreSQL, distributed systems, for example, Kafka, RabbitMQ. Stateful applications that require persistent storage and stable network identities, for example, Elasticsearch. Key features: stable network identities. Each pod gets a persistent DNS hostname based on its index, for example, MySQL 0, MySQL 1. Persistent storage. StatefulSets use persistent volume claims (PVCs) to maintain stable, durable storage for each pod. Ordered scaling. Pods are created and deleted in a strict order, ensuring stability during scaling up or down. Pod management policies. Choose between ordered ready, sequential, or parallel updates for your pods. 5. Init containers. Definition: Init containers are specialized containers that run before the main application container in a pod. They are used for initialization tasks, such as setting up necessary environment variables or pulling data before the primary container starts. Use cases: running a setup script before the application starts, waiting for external services, like databases, to become available before starting the main container, performing tasks like database migrations or pulling configuration files from remote sources. Key features: sequential execution. Init containers run one after the other in the specified order. Isolation. Init containers are isolated from the main containers but can share volumes. Retries. If an init container fails, Kubernetes retries until it succeeds. Conclusion: understanding and leveraging advanced workloads in Kubernetes can significantly improve the way complex, stateful, or infrastructure-related applications are deployed and managed. StatefulSets bring order and stability to stateful apps, while DaemonSets ensure critical services run on all nodes. Jobs and CronJobs handle one-time and recurring tasks, and init containers allow precise control over container initialization. These components unlock more power and flexibility for running complex workloads at scale,